Okay, you can create electrical energy just like we've talked about with conservation of energy. So if we have some sort of energy source, okay, so let's say it was chemical or something, so that's our E source. By some sort of transfer method or some sort of device, we can then create some sort of electrical energy. And what does that do? Well, that flows as some sort of current to then power something like a light bulb. So, how do devices do this? Well, what we can start off with is a power station. So we can name a few. So power station will transfer things into electrical energy. Okay, so we can name ones like an oil power station, gas, coal. So there's obviously the ones that aren't that good. You've got a wind turbine. You've got solar power. You've got nuclear power. You have tides, geothermal, and importantly, hydro. There's a few others you can look at too. Now, there's also one that you can use in your, let's say, classroom. You could use a battery or a cell. So those are also important. Now, in class we looked at the idea of a generator. So we looked at a handle you turn and it had a little belt attached to some coils of wire that rotated inside a magnet. So these things rotated like this. Those coils rotated a magnet, and that created some electrical energy which could then create a current to make a light bulb go. Now, most of these power stations use the same principle. So, for example, oil, gas, coal, a wind turbine, nuclear, tides, geothermal, and hydro. They all use that principle of turning a coil or a magnet inside a magnetic field, and that can create some electrical current. Now let's look at the conservation of energy associated with these things. So what you do, remember, we start off with some sort of energy, and through the device we then convert it to electrical energy. So the first one would be, let's say we look at oil, gas, coal. Okay, so these ones here, they all essentially are chemical potential energies, and through burning, or let's say heating water to make steam turn a turbine, okay, which you could say is some sort of kinetic energy, can then be formed into electrical energy. So we've got chemical potential energy, goes to kinetic energy, goes to electrical energy. Is there any others that will do the same thing there? Let's have a look. Nuclear actually does a similar thing. So instead of starting off as a chemical, it starts off with nuclear potential energy. And then heads off in the same path. What about tides? wind turbine, they actually skip the idea of making steam. They directly turn the turbine. So they are actually the kinetic energy of the tide will turn the turbine, which is kinetic energy, and that will create electrical energy. Same with the wind turbine. The kinetic energy of the wind will turn it and make that one go. Hydro, well, that again, this one actually, with a hydro dam, you actually store water. Let's make water blue, shall we? You store some water behind a tall dam. Oh, why have I made the dam blue? Let's make it green. So there's my dam. And this height, call it H, makes gravitational potential energy. The higher we raise the water, the more energy you can get from it. So that water will flow down here through a pipe, turn a turbine, which will then create your electrical energy to your wires. There's some sort of power pole. Okay, so in this case, it's gravitational potential energy that then turns the turbine, which is kinetic, and it makes electrical energy. Geothermal, well, that actually uses steam already made, so you don't need to use oil, gas, coal to make the steam. So that effectively can again skip all this and get to the turning of the turbine. So this one is kinetic energy to electrical energy. So what you could do, you could actually look at a dam. Okay, so let's have a look at it. So we draw a dam like this. What we do is we store water, okay, and we store it at a height for greater GPE, gravitational potential energy. Now this water will go through some channels, okay, penstocks, what you want to call them, goes through there, okay, and they hit a turbine. So you could say that there is some sort of kinetic here, or it could still be gravitational potential energy. Goes in, hits the turbine, and that then turns the generator, which in turn creates the electrical energy for your house. Now, what do these things actually do? Well, won't look at that one. What do these things actually do? Well, what they do, so what they can do is they can move charges around to create a potential energy, which we call a voltage. Okay, so what a magnet can do, is if you had a wire and we move it in a magnetic field. So let's say past the magnet. So here's my magnet over here, north, and the other end of the magnet over here, south. We move it past. What we could actually do, we could actually force electrons in this wire up to one end. Now remember, electrons repel each other. Okay, so electrons repel each other. So if I had a wire when somehow with a magnet or some other way we've forced electrons up to one end, a whole lot of electrons, So we've got some sort of force pushing them up there, then they'll be in a state of tension. Sort of like if we grab a pin and puncture the top of this pipe, then we'll have a fountain of electrons flying out because they've all got this pressure built up. So what actually does happen is, well, instead of popping it like it was like a balloon, what we do is we can actually continue the wire around so it goes from one end to the other. And what happens then is electrons then flow out because they're trapped. They push the electrons that are in the wire around, and then it actually balances it up so that all the electrons try to get balanced. If this force continues, then this flow will continue. If this force stops, then the electrons will flow until there is an even spread amongst the electrons. Okay, the last one is that a cell does the same thing. So if we had a cell, plus minus, actually let's turn that around. What happens here is there's some sort of chemical reaction inside here. So this is your chemical potential energy that pushes electrons to this end, okay, or an ion that has got too many electrons, okay, so lots of electrons here, and they all don't like each other. So this reaction in here is making some sort of potential where the electrons are so built up they just want to explode out. So if we gave them a passage to flow out from here, let's say through a device and back to here, then these electrons will start flowing and pushing the ones that are in the wire around the circuit. And they'll try and balance up. But if this chemical reaction keeps going, more electrons keep getting pushed up to one end, okay, and the cycle will continue until that chemical potential energy is used up and you no longer can separate those charges. Now, as these electrons are moving around, they collide with things. So if we had a fast-moving electron and there was a wall in the way, okay, there's a whole lot of these things flowing in a circuit. Some will miss the walls, some will hit the walls. As they do, this wall will glow, okay? It'll create some heat, it'll create some sound, it'll do whatever the device is made to do. And so the energy has come from chemical potential energy, goes to electrical energy in the wires, and then comes out of the device as probably usually something like heat, light, sound. It could even make motion, so kinetic. So all different types of energy.